Alright kids, welcome to this video. I'm currently playing PC Building Simulator, and I'm going to be building a pretty basic computer and just really do a rundown of the hardware components that you will be learning this year in ICS3U. So let's get started. Right now, what you see on my screen is that I'm going to be working on a computer case. This is just the way the game works. You kind of have to have a case first and install all your components. So it's not my preferred way of planning out and thinking about a computer build, but we're just going to be following what the game kind of recommends, and I'll be adding some commentary along that. So I'm going to be working on this PC, and as you can tell, I kind of already took off all the side panels and whatnot because you didn't need to watch that, but here we go. All right, so you're looking at a bare bone chassis of a case, and we're going to be installing some components on it. And I think based on how this game goes, I have to place a motherboard first. So I'll show you a motherboard. And what the game, I'm hoping it nicely did, although I did type out ITX. Oh, there you go. It says incompatible. So I do need to put in an ITX size motherboard. What this means is that we just have a case that can't support a very big motherboard. So ITX meaning one of the smaller, or D one of the commercial smallest motherboard size, and by using something like this, we are sacrificing like connectivity and some features that other bigger motherboards might have, but we're also gaining that we get to build a smaller computer, which might be more beneficial for you. All right, so for this build, I decided to go AMD. So I'm going to pick a motherboard that supports an AM4 socket, which means that it only can support CPUs that can be installed on an AM4 socket. All right. Whereas here I have a Intel-based motherboard because it has a socket labeling of LGA 1200. So this motherboard, even though it's made from Gigabyte, it was designed so that it only supports Intel-based CPUs with the socket type of LGA 1200. Okay. So for this build, we're gonna start off with a motherboard, and we're gonna go AMD just because like that's the one that I've built most recently and whatnot. So here it just gives us a lot more specification. The chipset of B550, most often motherboards will have different rating of chipsets, and every year there will be maybe a different naming convention. So you do have to do a little research, but the B550 should be okay. So let's install that right there. We're gonna need to screw it in. There you go. So I think what the game forced us to do was install something called standoffs. Standoffs, they allow our motherboard to not be shocked. They allow, basically, like you're installing an like electrical component on a metal case, right? So we need standoffs to create separation between the metal or the metallic of the case, and so that we don't short circuit our build. All right. Let's see. We're going to open our CPU handle here because the next thing that we are going to install is a CPU. When I do a computer build and really plan it out, I like to buy my CPU first. But in this case right now, just to work with this properly, we're going to install the motherboard onto the case first and now choose a processor. So let's install a CPU. Okay, if you notice, like we're going to have some even AMD CPUs that are incompatible. That is because certain motherboards will only support for a certain number of what's it called processors, and if their socket types don't match, in this example, even though it's an AMD CPU, the socket type is TR4, we can't install this onto our motherboard. Right? I do want a newer generation of motherboards, I mean processors to install. So let's see what they have. Yeah, we're gonna go pretty basic. We're gonna install the 5600X. This, when the Ryzen 5000 series came out, this was usually the starter CPU. It was very good. It's very good for your money and whatnot. And let's look at the specs. Okay, so frequency is how fast our processor can process information and do calculations. And if you notice, it's 4600 megahertz. Okay. And whereas if we were to look at this Ryzen 7 1700, which was the first generations of Ryzen CPUs coming out, right? Its frequencies clocked at 3700 megahertz. So even through these generations of improvements, you can really notice the frequency differences. Now we have cores as well. Cores often help CPUs handle multiple instructions, and it really depends on the programming of the software. Certain software are only programmed to use a single core, so really you don't really need a lot of cores if all the programs that you're using only use a single core. But as we're in 2023, most developers are now trying to use and utilize all the cores of your CPUs as possible. So a good metaphor for cores is that if you go to a grocery store, you go to the checkout. If they only had a single cashier open, that would be a single core system. Whereas if you start to add on more and more cashiers, you have more cores processing more customers at once. Now it gets costly for a grocery store to install more cores, right? More cashiers to their system, they have to pay more money. So in this case, with the processors, the more cores you add on, the bigger the processor gets and the hotter it'll run because it needs more power to generate that. Therefore, as newer generations come out, they are really shrinking down the sizes of our capacitors and the technology within your CPU. Okay, so you might see like um, older generations having more cores and like relative speeds, but it's because they might run hotter or they might use more power and whatnot. Okay, but in this one here, we're gonna be using the AMD Ryzen 5600X, and we're going to install it in this CPU socket. So if you look at this motherboard right here, this is a socket, and we are using a compatible AM4 CPU so that we can install that into our AM4 socket. Okay, and we're going to close our CPU handle. Boom. Our processor is installed. Now, I can't zoom in any further, but if you notice this little corner here, there is that little golden triangle. That marking is there on most modern CPUs to tell you and to indicate that this bottom corner should be matching the bottom corner marking of your motherboard as well. Okay. So in this game, it kind of just did it automatically for us, but most often you'll have to line that up as well. Now, this is a processing unit for our computer. It runs really hot because we're sending electricity, and that component is translating that into binary instructions so that our computer can do its thing. So we're going to install a cooler. So let's go into CPU cooling. All these are great coolers. They have fans, so these are air-based coolers, so they're using air to cool the component. And if you notice, they'll have these little metallic components there called heat sinks, where they transfer the heat, the hot heat, from the processor, and we're kind of blowing these air out with these fans. So we'll just find one that will fit, and let's actually no, Be Quiet is a much better brand for cooling. Let's do this one. It should be pretty good. We'll be using the Be Quiet Dark Rock cooler. It's fantastic. It'll tell you what socket it supports. We'll install that in. Whoa. I have no idea what's going on. Okay. Is there any way I can... Oh. It looks huge. Okay, but we've installed it. Let me remove. It's usually not that easy in real life. Just like put on a cooler like that, right? But right now, what we forgot to do was we installed a cooler, but we didn't put any thermal paste. So we got to put thermal paste first, and we're gonna apply a little thermal paste there, and we put a little dot. Basically, what thermal paste does is that even though our CPUs look very flat, like crystal flat in terms of with our naked eye, but if you really zoom into the let's say pixels zoomed in onto your pixel, it will actually look very zagged. So we are filling that gap with thermal paste so that we can transfer heat from our processor to our cooler as much as possible so that we can effectively cool this component so that it runs at its optimal temperature. All right, so now let's reinstall our CPU cooler. We were installing a Be Quiet cooler, and we'll install the Dark Rock like that. And that looks great. Awesome. I've installed a cooler, and at this point, I don't think this is going to let me install my next component, which would be memory. It's RAM. We want a RAM. This is our short-term memory of our computer, and really, like, you've noticed that if you have higher RAM, your computer kind of feels like it's running faster. It's because we can load more processes onto your computer, and having a greater storage for your RAM allows us to have more processes running so that our computer runs smoother, especially when Google Chrome eats so much of your RAM data. It kind of boggles down your computer at times. Therefore, you just have to improve your RAM to have more oomph and speed to your computer. All right, so what I want to do is, the basic should be in 2023 that you're installing a 16 gigabyte worth of RAM. Let's see if they have it in proper setting. They do not. Let's see, 16 gigs. Now, when you do install RAM or buy RAM, you do want the speed to be high as possible. Faster RAM is tends to be better. That way, like the speed of it, the speed of the RAM communicating with your CPU will be better. And the bigger the storage, there's more processes, more things, more software, more apps you can run at the same time on your computer. Okay. So let's go with this one. We're going to need to remove this guy, and we're going to install Corsair 16 right here. And we're going to be installing that. Oh, they want me to open up the memory clip, which awesome. You do that in real life as well. And then we install the RAM. And oh. Wow. They're making me install one at a time. Here, we want to install 2. So we're going to go 8. We don't need to write 16 gigs. So we'll install that there. And we'll install another one there with our memory chips open. There we go. The reason why I wanted to install 2 is, first, I wanted to have 16 gigabytes of RAM. But secondly, motherboards will have something called memory channels, and most often, if it's a dual channel memory, it means that it likes to have its memories of pairs of 2 and same memories of pairs of 2. So in this case, most likely this ITX board has 2 slots. I am betting that it's a dual channel memory, and it likes to have 2 memory RAM sticks installed for optimal performance. All right, so we're going to need to install thermal paste again right there. Beautiful. And then we're going to do our cooling with our Be Quiet. There you go. And we're just going to stick that guy in there, and we're good. No. Oh, there you go. Okay. We have installed RAM, which is a short-term memory, bigger the storage, more things and more applications we can run at the same time. We've installed a CPU in our motherboard, which stronger the CPU, the faster your computer will run, because faster will process data. We had to install a cooler because it runs really hot, because we're sending electricity to our CPU and it's translating that to binary information. So to cool the very, very hot CPU, we're using a air-based cooler in this build, where we can have this cooler hopefully mitigate that heat and out of the CPU and out into your room, let's say. All right, it would be nice to game with this thing, so let's say that we want to game, but I think it's going to get in the way of us actually installing our power supply unit. So we're going to install our power supply unit. Wow. A lot of these power supplies are incompatible because they don't fit a smaller case. We're actually going to need an SFX size. So form factor. Form factor is a fancy word for installing, or it's a form factor is a fancy word for sizes, different sizes of components. Okay. And for this build here, 750 watts should be more than enough. We're going to we're going to need missing parts. Let's see. We need to have a bracket apparently. We're gonna need to install that there. Then our PSU. And we're gonna install that. And there you go. We were able to rotate, and we have our little power supply. Beautiful. Okay. All right, so we have a power supply installed. I was just a little worried that we weren't able to install this without having the graphic cards there. And what I want to do is actually really remove this component again because I forgot to install a hard drive. So we're gonna open this drive bay and install a hard drive. So this is usually under storage, and we're gonna look for an NVMe storage. NVMe is a special type of SSD that can be installed directly onto your motherboard without using a wire. And for our sake here, let's look for 1 terabyte. Yeah, that looks good enough. We're gonna install it right there. Oh, I don't know what's not letting me install. Alright, this is fun. It's not letting me install. Let's try a different NVMe SSD. We'll use one with the... Yeah, we'll use one of these guys. There you go. Wow. Alright, and we're gonna... You notice here we have installed an NVMe, and this hard drive has installed directly into our motherboard. In the past, you would have to actually use one of these connectors here and use a wire to connect the solid state drive or a hard drive. But with recent developments in hard drive technology, they have developed these hard drives called NVMe solid state drives, where they're extremely fast because they're installed right into your motherboard, and they're smaller, but they're just as strong as normal SSDs, and they're really easy to install. And we're gonna close that back up, and then once again we're gonna have to put our thermal paste onto our CPU and install our cooler. This should be the last time that we do this. Boom, there we go. I've installed our cooler, we installed a hard drive. That's where you install all your software that you need for your computer. We have installed RAM so that our CPU can remember things that it is processing, and bigger the storage size of that, more things you can run at the same time while your CPU is processing things. Okay, now in this slot right here, we're gonna install a GPU because we want to be able to game in this computer. So let's look at a graphics card and see what this game offers. Wow, it has a lot of good graphics card, but we're gonna go for an RTX build. Let's see. Okay. Let's look for an RTX 3060 Ti. So anything over that will be a overkill. Okay, perfect. We have installed a graphics card, and that's what it does. The reason why we install a graphics card in this case is twofold. The processor we bought doesn't really actually have any graphical capabilities. So in this computer, if I were to plug in an HDMI cable right here, without the graphics card, or actually just in here in general, our processor doesn't have the graphical capabilities or GPUs inside its CPU, so you're not going to get any output. Therefore, we actually had to buy some sort of a graphics card for this computer so that we can have graphical output. Okay, and this is a GPU. GPU itself is like a microcomputer. It has its own processing unit, which is called GPU. It has its own RAM, which we call VRAM, and it has its own motherboard. It doesn't have storage, but it's a component just strictly dedicated to do graphical work, and we installed that right there. Okay, So basically our bases of our computers are done. So I'm just going to do some cabling. We're going to say we're going to connect the air cooler right there. Boom. What do we need to connect there? All right, let's connect our motherboard to our PSU. So we have that little cable there. Beautiful. And then we're going to connect our cables to our GPU so that we can power that as well. We're going to connect their case to our PSU. Oh, okay. We now have power. So we have plugged in the power to our computer. And we're going to connect our power button to our from our case to the motherboard. Perfect. And we're going to also connect our CPU port. This is the port where we power our CPU, and we're going to connect it to our PSU. If you notice, we have these cables all installed. Okay. So we have now installed the bare components of the computer. I'm going to try turning it on. Okay, so it is running. Beautiful. So what we're going to do now is that is the HDMI cable for our graphics. It is running. It's saying no keyboard. So let's connect our keyboard right there. Boom. And that's going to be our mouse. Let's connect that right there. To use computer, no keyboard. All right, so we're going to power off the computer, and we're going to try running that again. Yeah, our case is incomplete, but that's okay. No OS found. That's okay, but our computer's running. So basically, these are the main core components of your computer. We started off with, well, a case, and we installed a motherboard. Onto that motherboard, we installed a CPU. Basically, the socket type has to match, so that if you got, let's say, an AM4 motherboard, then you have to get a CPU that is AM4 socket, so that you can install that processor onto your motherboard. Okay. And then, we have to get RAM. RAM's a short-term memory. Stronger the RAM, the better the RAM, the more applications you run at once, as your processor is processing all the information that you do with these softwares on your computer. Okay. A CPU needs a cooler because it runs hot, where it's sending electricity constantly, and it's translating that to binary information, so that we can now, once it gets really hot, we can let it run at optimal temperatures by installing these gigantic air coolers sometimes, so that we can cool our CPU. And certain CPUs don't have graphical capabilities. These CPUs don't have GPUs, okay? Therefore, we need to install a graphics card so that we can have some sort of output on your monitor, okay? This was a very quick rundown of what a computer build is and all the, the essential necessary components that go into a computer, okay? For more questions, you can always ask in class, but until next time, have a great day. Bye, kids.